Hey everybody, this is Jono from Seneca. Today I'm going to be talking about the Haber process. Now, this is part 2 of the Haber process or Haber process, however you want to say it. I don't mind. Make sure you check out the first episode so you're fully up to speed, and let's dive in and get some even more juicy details about the process. Now, quick reminder, what's the equation for the Haber process? It's nitrogen plus hydrogen goes to ammonia, and some heat is produced too. And this reaction is reversible, so it goes both ways. Do you remember the chemical symbol for ammonia? That is NH3. Okay, so now we've had a very quick recap. Let's go on to talk about the trade-offs in the Haber process. Now, this reaction produces ammonia and it's reversible. And because of this, changing the conditions affects the position of the equilibrium. Okay, so let's start off by talking about temperature. Now, the forward reaction is exothermic, so it gives out heat. Therefore, an increase in temperature moves the position of the equilibrium towards the reactants. So that means there's a trade-off between increasing the rate of the reaction by increasing the temperature and reducing the yield because of the high temperature. So basically, high temperatures are good because it means the reaction goes faster and the molecules are colliding more frequently. But this high temperature favors the reverse reaction because the forward reaction produces heat. So if we add even more heat, the system's like, I need to get rid of all this extra heat that's up in here. So it's going to do the reverse and do the reverse reaction, breaking down ammonia into nitrogen and hydrogen. Okay, so it's a trade-off with the temperature. Now, pressure, there are fewer molecules of product than reactant. Therefore, increasing the pressure moves the position of the equilibrium towards the products. Increasing the pressure also increases the rate. So, sounds great. Let's just have the highest pressure possible. Well, we don't do that either because it can be expensive and it's to have such a high pressure, and it could also be less safe. There's more chance of like explosions and stuff. So, in this process, there is a little trade-off. Okay, so let's go through that again, just to summarize it so you remember it for your exam. Now, temperature. What happens if we increase the temperature? Well, the good thing is we increase the rate of the reaction. Remember, higher temperature, higher rate. So the reactions go faster, but remember, it's reversible. So increasing the temperature does increase the forward and the reverse reaction. A con of a high temperature is it decreases the ammonia yield. Remember, the forward reaction that produces ammonia is exothermic, so it gives out heat. Therefore, if we add more heat, the system is like, I don't like change. I like it the way it was. So it shifts the equilibrium to the left, so we make more of the reactants, okay? So that's the trade-off. With pressure, do you remember the pros? Well, high pressure is great because we increase the rate and we increase the yield, but it's expensive and it's dangerous. Okay, so quick question. Why do you think the commercially used conditions for the Haber process might change slightly? So commercially used conditions can change to account for changes to the cost and availability of energy supplies and raw materials. So that just means that, like, depending on what's going on in the world or in like the economy and all that kind of crap, the conditions used in the Haber process might change just a little bit. Okay, so that brings us to the end of this episode. Hope it was useful. Make sure you check out the other episode so you feel super confident about the Haber process, and keep up all your revision.